Good evening, everyone. I hope my voice is clear. If there is some issue with my voice, you can tell me. Accordingly, we can adjust. So, it is wonderful to have all of you on board. This is the first stream that I am doing. I have been speaking about these two topics at various places, and I have been getting some requests to put something online and to do some live things, so I thought that I should do it. So we are starting with basics, and T-test and ANOVA is something that we are starting today with. I hope what I am speaking is audible to all of you. If it is not, then we can kind of do the adjustments. So I am in constant touch with the chat box also, so I know what you are typing and if you are not typing. So you can let me know by typing into the chat boxes and all, right? So let us start. Uh, let us start, and I hope that we can kind of touch upon the basics of today. Okay. So uh, I'm now taking you to my slides. So first of all, let me tell you that we are kind of let me do some adjustments. I hope you are getting some problems with video. Let me check the buffering and all. Maybe you are getting some buffering issues. Uh, I'm fixing up the things. I hope it will work out. Okay, is this visible to you now? If you can tell me. Good evening, Monica. Good evening, Neeraj. Wonderful to have you on board. So I'm starting now. I hope that T-test and ANOVA, because all of you are here, so that means that you are interested in knowing about this. So I am just interested in knowing, so you can drop me into your chat box if it all is known to you, or it is the first time that you are kind of hearing about these two terms. So this will actually help me in understanding to what extent can we go in detail, and if you are kind of heard about it, so I think that we can start straight away. So I am taking you to my PPT first, and this PPT is something that uh, let me take you to my PPT. Okay, so I am starting with T-test and ANOVA. Let me first start by telling you that T-test and ANOVA are two very basic, very basic, tools for any researcher, and it is all about to understand the variation in the data. And first of all, I think I should be telling you that why on earth are we talking about T-test and why are we talking about ANOVA? Because it is important to understand the very basic thing of it. And to make sense of that, I would just like to tell you that how important is this variation for our data. So when we know this, we perhaps would be in a position to understand that why t-test and why ANOVA. So first of all, the first thing first, let me put up this disclaimer to all of you. When I am presenting this, and whenever I present anywhere, I just make it very clear. This thing coming from Carl. He was of the opinion that there have been only three epoch-making mathematicians world has ever seen, and these were Archimedes, Newton, and Einstein. So obviously, I am not one of these. So I am when I am discussing this with you. So please treat this as to be a general discussion. I am not an expert, so you might also type in something, and we also can kind of learn from each other. So I'm. It is kind of a discussion that we are trying to do. So there is something I know, there is something that you know. So this is how we will generate the discussion. Okay. So first of all, let me tell you about the variation. This variation, this question is so important. I mean, before starting of this t-test and ANOVA, first of all, we have to think about that why on earth do we do research? I just want you to spend a little time on thinking about this, that why do we do research? And perhaps we can understand this by looking at this slide. What I am showing you now, these are some pens, and why I am showing you this slide is because when you would look at these 5 pens or 6 pens or 7 pens, uh, if I ask a question from you, that suppose I pick up one pen out of these 7 pens, and if I ask you that by looking at this one pen, can I say all these pens are like this? So in other words, what I am asking from you is that if I take up this one pen and if I just study this one pen, and can I say that whatever I have found out of this pen, I can kind of replicate, generalize to all the pens which are there? Perhaps we can say so, and there is a reason why we can say so, because all of them are equal. Now let me kind of change the scenario a little bit. If you look at this part of the slide, which is the left hand part of the slide where I have shown you 5 pens, can here we do the same thing? Can here I pick up this one pen, and can I say that all pens are like this? Perhaps our response to this would change. And why this response would change is because these pens are not equal, right? When we look at the right hand side of the picture, where is this lot of pens you can see, these pens are of of the nature that perhaps I am not in a position to pick up any one of these pen and can say that all the pens are like this. And why we are not able to say that? So the thing which I've written in the bottom is the answer to all this, and that is the variation. You see, I just want to imagine that if all the pens that exist in this world, if all of them would be of absolutely same nature to each other, uh, we would not perhaps be choosing up all the pens, we would not perhaps be talking of sample, we would not perhaps be talking of sample size, we would just pick up one pen out of that, and we would have said that every pen which exists under the sun in the world is like this only. But because there is this variation, so if you would look at it from the management and the research angle, the marketer, the manager, whenever he or she is trying to do research, he would wish that if every consumer whom he is serving was same, absolutely same. But actually, that is not the case. Imagine that entire country, our country, all of the people who are living in our country, they are absolutely equal to each other. So would we be then talking of sample size? Would we then be talking of uh, doing the generalization of the data, because I would simply choose up one individual and I would say that everyone is like this. So why I'm telling you this is because it is this variation which is very, very important to understand. If there is no variation, there is no research. That is what I want to tell you. So that question that I was asking you, that what is it because of which we are doing the research, what is perhaps the most important question uh, which actually makes us to do the research, and that answer is that it is the variation. You take the variation out of everything and perhaps we need not to do any kind of research. I just give you a hypothetical example. Suppose you are in a class. If there are 40 students in class, and perhaps there are only 4 types of students in this class, so the 40 students can be segregated into 4 homogeneous groups. So the number of people that you need to pick up from this class to do a research onto this would be only 4, because one individual picked up from this one group would represent the entire group, because in this group all the people are like this only. Similarly, the other group, second group, you choose any one out of them, and you say that all entire group number 2 is represented by picking up the second fellow, and similarly for third one, and similarly for the fourth one. So what we are trying to understand here is that it is the variation which is deciding our sample size. So there are 4 type of students in this class, and hence the sample that we need is 4 only. Had there been 5 type of groups, we would be talking of 5 sample size. So it is depending upon the variation, and that is why maybe we will do this also to establish the sample size of the data. We would see that more the variation in the data, perhaps the larger the sample size that we require, right? Why is it important to understand is because if I can kind of explain it like this to you by going into this Word document. If I have 60 people, the sample size required maybe only say 10. If I have 100 people, uh, how much sample size? See, this question is important because uh, we cannot comment on to the answer of this question unless we do not actually come to know about the variation of the data, right? So variation is important. This is what I want to tell you. Now for this population of 60, this size of 10 might be sufficient, but if in the same population you increase the variation, this thing would go up, the sample size required would go up. So variation is the thing because of which we are doing this, right? You know that formula also. I hope this sample size determination formula, which says that the sigma square, right, multiplied by z square and divided by the precision level, right? So when we are kind of looking at the formulas like this, we will do this formula. We would actually come to know that it is onto the sample, it is onto the variation. You see, the sample size, if I can write it with s, this is directly proportional to the square of variation. Larger the variation, larger would be your sample size. So this variation is at the heart of it. So this is so much important to understand. You go to any of the statistical technique, you would invariably realize that if this thing is taken out uh, of the data that you are gathering, the variation, you perhaps would not need to do the research, because everything is very much visible, available to you, and you just would end up in choosing one, and perhaps that one thing is sufficient, and you need not to do anything else. So now when we talk of t-test, when we talk of t, so we today will discuss t, and we will discuss ANOVA also. So both these two techniques, are basically the technique of measuring the variance in the data only, right? They are the techniques of measuring the variance in the data. So this variance is important, right? So now let us start up with what the T do to us and what the ANOVA do to us. We were just a while ago talking about the sample size. Suppose in our sample we end up in choosing 40 people, right? And out of this 40, suppose we have male and we have female. So I'm assuming that, suppose for the sake of understanding, I'm saying 20 are male and 20 are female. Now suppose let us take this as the mean height of the class. So you can go to these 20 males one by one, and you can measure their height, and you can come to know the average height of the male, and you say it is 165 centimeter, hypothetically I'm saying. Similarly for female, you can go and you can measure the height of each and every student, female student, and you might measure the height, and you might say that it is 164.5, hypothetically I'm saying. When you are looking at this, many times we are in a situation wherein we have to speak about the relevance of difference in the two groups that we are talking. We are invariably trying to understand that the average height of male is 165 and average height of female is 164.5, and for male it is 165. So invariably the difference is only of 0.5 centimeter. The larger question is, can we, by looking at this data, can we say that male are taller than female, whereas the difference is only 0.5? This is the question, which is an important question. So when we are actually, looking at it with our naked eye, looking at it statistically, looking at it from the mathematical perspective, we can very clearly say that yes, male are much taller than the female, because you have a difference of 0.5, which actually is a mathematical difference. So 0.5 is a difference. Math says 0.5 has a sense. But the research says, and that is where you come in as a researcher, you would ask, does it really make a difference, this 0.5? Do we really say that the male being only on an average taller 0.5 a centimeter are actually taller than female? Can we come to this generalization? This is something that is an important question. Now this thing we just can very plainly say that yes, male are taller, but the statistics and the research says no, we cannot say this. Otherwise, why would we need the tests? And this is where the tests like Ttest and ANOVA comes into picture. What we are trying to understand, that whatever is the variation in these two groups, the variation is in the form of means. Whatever is the variation in these two groups, is this variation large enough so that we can say that male are taller than female? This is a larger question. The difference is only 0.5. Now, why I started with that PowerPoint, wherein I was telling you that it is important to understand the value of variation in everything that we do in research. If I am to tell you, now let me kind of come down and let me tell you, suppose in this population size of 40, we have male and we have female, right? This is what we have. So we have kind of 20 male, we have 20 female, and the difference between their height is 0.5. That is something that we know. Now if in this data, so I'm talking of this standard deviation, if in this data the variation is 5 centimeter, standard deviation is 5 centimeter, hypothetically I'm saying. This is case number 1, so I'm writing it as C1. Now let us talk of C2 and change. Suppose hypothetically we say that no, the variation is not 5 centimeter, it is 10 centimeter. Oh boy. Now this difference that we are talking here is only of 0.5 centimeters, right? We have to comment on, by only having this 0.5 centimeter as a difference, do we call male as to be taller than female? This is our question. Plainly, we can say that yes, male are taller, but then we are going to test, and the test is actually telling us, it is not telling us because we are not yet applied the test, but we need to look at the variation in the data, because on the basis of that we would say that whether the male are taller than the female or not. If we are looking at this 5 centimeter as standard deviation in this entire data of 40 population, we might interpret this 0.05 as a different thing, and this is very important that I'm telling you now. If this population is having a standard deviation of 10 centimeter, we will interpret 0.05 differently now. It is all the game of this variation, right? Maybe for a lower amount of this standard deviation, the lower difference in means still be significant. For a larger standard deviation, we would require a larger difference to be able to call that yes, this difference is sufficient enough that we might say that males are actually more taller than the female. So we cannot look at it plainly and we can say that yes, they are taller, they are not taller. So this is where the t-test would come into picture. So t-test essentially does what? T-test is basically called as a difference of mean test, and it uses variation. So difference of mean test would mean whatever is the difference in the means of the two group number 1 and group number 2, this is 0.05. Is this difference significant enough so that we can say that the male are taller than female? This is what the t-test would tell us, and that is why it is called as the difference of mean test, right? So this is what the t-test do. Now taking you into this and to tell you that what does it actually mean, let me tell you something more about the t-test and all. So first thing first, we were here, and let me come down so that I can tell you more about t-test. So essentially what we have discussed is this: t-test, it is a difference of mean test, right? It is a difference of mean test. It tests whether the difference between two groups, difference between the mean of two groups, is significantly different or not. This is what we do in t-test, right? Okay. Now maybe this is something that we will kind of check, and when we are doing this, we talk of null hypothesis. So null hypothesis for t-test is there is no significant difference between the mean of two groups being studied, right? This is what we do. Having said that, we should know at the first place the means in order to check whether there is difference between these two means or not, or the mean of these two groups or not. Now for that we need to have data, and that is why we always need data to analyze anything, so t-test is not an exception. So now let us also look at some important thing which many of times is creating problems for our for the scholars who are willing to apply these tests. There is an assumption to t-test and the ANOVA also, and very important assumption. Important assumption is that there should be homogeneity of variances of the two groups whose means are being studied. This is what we are testing. There should be homogeneity. If this condition is not met, then we have to look at t-test as to be less, as to be not believable. Look at t-test as giving unreliable results. So we need to test it. So test the how to test the homogeneity of variances? How do we do that? So we were looking at these two groups. So group number one was male, group number two was female. So what essentially this assumption means is that whatever is the variance of these 20 male as far as their height is concerned, because we are talking of the height of these people, this should be homogeneous with the variance of these 20 female. And the logic behind this is that because both these male and female are actually picked up from the same population. So if they are picked up from the same population, they must have almost equal variance, right? So this is the idea behind this. So meaning thereby that we are kind of saying that this test actually has this assumption that the variances should be homogeneous, and this must be tested. So there is a statistic which actually tests this, and that is called as Levine statistic. Wow, Levine. Levine statistic tells us whether this condition is met or not, right? Whether the two groups, these two groups, are they having variance as homogeneous or not, right? So Levine test helps us in doing that. And how does it do this is, for that let's go to SPSS, because always better to look at the real practical things, because that would make the things more clear to us, right? So I am now taking you to SPSS thing. So I have a sample file with me. I would kind of open it up. So this is a file which actually I have taken to do the dummy testing of this t-test, right? And there is one more thing which perhaps I must tell you. That perhaps I will tell you when we are doing this SPSS analysis using the t-test. So let us do this now. I have this data, and this data is a hypothetical data. It's not a hypothetical data for that sense. It is like, it is just to understand that how do we look at the thing. So what you are looking at now is a variable file, and this is the data. And so these are the questions. These are the questions. So these questions would actually, are like, I like this advertising much. This is about advertising study. So we have 5 options to this. So like strongly agree, agree, neutral, disagree, strongly disagree. So someone would be clicking to this, someone would be doing this, someone would be doing this. So this is how they would be doing it. So now suppose if I go to analyze and if I go to compare means, let me change this. Let me do so, because you are not seeing this analyze thing. Let me make it little more available to you so that there is no problem. Okay, so now it must be visible to you. Yes, we are good. Yes. So I'm going to this data file. Here is the data file. Okay. So now I have this data file. This is the data that I have. So you can see this data is all in strongly agree, neutral, and all that mode. So you can kind of see that you have this 2 3 2 3 thing happening, and it is because that in this I have given values to this question. So the question is, I like this advertising very much. So it says strongly disagree, agree to 1, agree to 2, neutral to 3, disagree to 4, and strongly agree to 5. Okay. So because in my data view, these are the labels, these are the values. You see the value is written here. So 1 is given a value of strongly agree. This is also called as coding in SPSS. So when we go to data view, so you can go to view and you can see I have unchecked value labels. So labels are not visible now. So that is why you are saying 1 1 2 2 2 3 4. So if I can go back and I can check onto value labels, you see that you can see now the actual labels and the values that were given to it. So if I can go to analyze and compare means, so compare means is the place where you will find Ttest and ANOVA both. Because we are comparing the means of the two groups, so we are going into the compare means. So we are going to analyze, we are going to compare means, and then we have the three types of t-test. I will tell you what these tests are about, but I am just to show you something. So for that I will go to descriptives and I will go to frequency. Yes. I will go to frequency and I am taking in this thing, which is I like this advertisement very much. So if I go to this display frequency tables, I click OK, I will get a output which will show me how the data is kind of distributed. So this is the total amount of data that I have, 210. So mostly people are saying agree, mostly are saying neutral. So its mean is going to be about agree, which is about whatever the value that we have given to it. So this is the data that we have. Now let us go to analyze again, and let us go to explore. I like this advertising. This is where I have kind of taken it. I think we need not to do that because it will kind of but still let us do it. Descriptives I am interested in because we are looking at a mean. So this is what we are getting out of this. You see, I like this advertising very much. Has a mean value of 2.09. That is what I was telling you by looking at this thing, because most of the people are kind of saying agree to it. So its mean has to be around 2.09. So this is the mean of it, right? Now this mean, if we split this mean into male and female, this is how we will get the two groups. So uh, going back, descriptives and explore, and if I can take the gender into the factor list and I say OK, so clicking onto OK would give me this thing, right? So for male the mean is 2.05 and for the female it is 2.11, right? Now when you will work along in SPSS, you will come to know about many things. Now for example, whatever the output that you get in SPSS, it is a pivot table. Because this thing is looking messy now, you can kind of correct it. So I am kind of double clicking it because I don't want this entire stuff, confidence interval, trimmed mean and all. So I have double clicked onto it. Double clicking it would give you this new window which is called as pivoting trace. As you have pivot tables in Excel, so you have pivoting trace in SPSS also, because many a times SPSS throws you something which you might not require. So you can kind of do this change. So you can see you have the rows, you have the columns also. So statistics, I can kind of bring statistics here, and that is making the task so much easy to me. You see this now. So I like this advertisement very much. You have male mean, you have female mean. Now everything has gone into the rows. Previously this thing was like, into the continuation of it. It is, there were many rows to it, but now, I have changed it because I was interested in looking at mean of male and female for I like this advertising very much. Now we have mean of 2.05, we have for male, we have mean of 2.11 for female. So how much is the difference between these two means? The difference is hardly 0.06. Yes, this is the difference that we are talking about, 2.05 and 2.11. Again, the same thing as I was telling you in the initial explanation of T-test. Can we say here that female like this advertisement much more than male because they are getting a larger score on this? Yeah, the difference is only 0.06. So the same thing comes into the picture again, because mathematically looking at, we can say that yes, female likes the advertisement much, but can we really say? So the larger question here is this difference of 0.06 larger enough, sufficient enough to say that female like the advertisement much more than male, and that too significantly? So for that we need to look at the variation into the data, right? And that is what the t-test would do in between. So I am going to analyze and I am going to compare means, and in compare means I will go to independent sample t-test. Let me very quickly tell you what are these three type of t-tests that we are looking at here. So this is like one sample t-test, right? This is independent sample t-test and this is paired sample t-test. So to make the things little easy to you, I will start with one sample t-test. So I am coming to analyze, compare means and one sample t-test. I have clicked here and this has given me this window, you know. So I bring this thing in because I am interested in this. So I have brought I like the advertising into the test variable things. Can you see here now? We have a test value column here, and this currently is like 0, right? Now this is a one sample t-test. Now what it is doing, a t-test primarily is testing the two means. That is what we are looking at t-test as. But here you are considering all the 40 people. Now that example that we took of class, if there are 40 students in class, here we have 201 people in this data. Now here this one sample t-test is considering 201 respondents of this data as one sample only, right? So there are no two samples here, there is only one sample. So I'm again telling it to you, we are here considering all the 201 respondents which is there in this data as one sample, and they have a mean, and we have calculated a mean. So this statement would have a mean irrespective of male and female. Now we can check whatever is the mean of this statement against any test value. So you see here a test value. So suppose I write 2 here. So what will it do is, whatever is the mean of this statement, is that mean of this statement significantly different from a mean value of 2? Right now, how do you use this one sample t-test? Now let me tell you this. Now suppose a hypothetical example. You say that 70% is a good score for any student in a class. I have scored 69%. Would you say that I have not scored good? So whatever is the average score of your class, you can compare it with 70. You can put the test value as 70 here, so that you know how is your class behaving as a standard, as against the standard value. So if you say that your class is the mean or the average of the class score is significantly different than 70, then you say that yes, these two are different, right? Suppose this thing is 72, your mean score of the class is 72, you test it against 70, here you would have typed 70 in that case. So if this would have come that yes, the mean of the class score and is different from 70, you would have said that the class is scoring way better than the standards, the normal standards, which is 70. So likewise, we take any test value, standard value here, against which we check the mean of this. So the things would be more clear when I press OK here. So I like test value 2, press OK, and this is giving me an output. And here is it. You see the two tables. So the first table says I like this advertising very much. It is for the 210 respondents. The mean value is 2.09. You see the mean for male and female were different, but this is the mean for everyone combined together. The 210 are considered as one sample because we are doing one sample statistic here. This is standard deviation. This is what, the death important thing, and this is why we are spending our time today. 0.784. So this is standard error of mean. So standard error of mean tells us that if you would have taken out of this population from where this sample is taken, if from this population you would have chosen any other sample of the same sample size, the mean that you would have got would be different by this much. This is what this standard error of mean tells you. So on an average, you will get this much of error by choosing the different samples from the same population. You will get a mean, and that mean might be different by this much. Right? This is what the standard error mean tells you. Now this is one sample t-test. You come to the below this thing, this table. So test value is 2. This is T being run for I like this advertising very much, and this value that you're looking here, significance, this significance is something that we need to look at whenever we are going to make our interpretations from the data. So this value is 0.115. Maybe we need to do the hypothesis testing, but here you can kind of learn it, you can kind of write it. There is a full explanation to it also, that why we do take it as 0.05, but this value needs to be checked against a value of 0.05. If this is larger than 0.05, this significance value, we say there is no difference, and if it is less than 0.05, we say there is difference. So because this value is larger than 0.05, we say there is no difference. Now, no difference between what? No difference between 2.09, which is the mean of this statement, and the 2, which is our test value. So we now would say that 2.09 is no different from 2 as a mean. So we must consider both these things as equal, right? So this is a quick thing about one sample t-test. I will quickly explain to you this logic of 0.05 also, but first let's look at let me quickly take you back to this thing, to my word thing, so that I can explain this thing a little bit to you. Now this is understood by looking at null hypothesis. Null hypothesis for t-test is there is no significant difference between the means of two groups. Yeah, this is what the hypothesis is. How do you remember this hypothesis? Because there are difficulties in remembering the hypothesis. So you can remember it like this, that the t-test is for difference of mean. So the null stands for no, it does not exist. That means it is void. So you can remember the null hypothesis for t-test is for difference between the means. This is difference between the means, and because it is a null hypothesis, so you say no difference between the means. This is how you can kind of remember it. It's a heuristic that you can take. It is a way of remembering it, just to make the things a little easy. So there is no difference between the means. Right? So this is the null hypothesis. How do you reject or accept the null hypothesis? You accept it if the mean value is greater than 0.05. You reject null hypothesis if mean value is less than 0.05. Right? So this is what you do. Now let us look at this in our this table. Right? So here it is 0.115. So what is happening? This is falling into this category. So that means we will accept the null hypothesis. And the null hypothesis is there is no significant difference between the means of these two groups. Right? So what are the two groups here? The one group is of 210 and the other is this test value, which is 2. So we would say there is no difference, and hence these two are equal. 2 and 2.0 are equal, and that is where the statistics comes into picture, because we say that there was a difference of mean, and here this table also tells you the difference is of 0.086. This is where I'm showing you, but this difference is not significant enough. We must not treat this difference, that bigger difference, that you say it is making a difference between these two groups, right? So this is how kind of we look at it. I hope it makes sense. So this is your one sample t-test. Okay, let me see if there are some questions around it by now. Oh yes, so Bharat is correcting me, 210 responses. Yeah, that is fine. Thank you so much for correcting me. Ravi saying, let me go back to my this thing. Yes, you are right. There are 210 responses. Okay, so I think we are doing good. Combination of chalk and computer would lead to better result. Yes, wonderful. But I have no option. I can do it like this only. Right. Okay. So now I am coming back to this data, and I am now going to compare means, and I am going to independent sample t-test. Wow, independent sample t-test, yes. So independent sample t-test does what? If I will click onto this, it will give me this window. Let me reset it. So I'm again bringing this thing in. This is the test variable. Grouping variable, because there are two groups. We do t-test for two groups. So let me bring gender in. So we have gender here. So I will bring the gender in, and I have to define groups. You see, there are two question marks here, right? So I need to define groups. And how do I need to define groups? Because I can go back to my variable view, and I can come down and I come to gender, and here is the two groups. So one is for male, two is for female, right? So I am cancelling it, because I know now the group number 1 is male, group number 2 is female. So I can cancel it. I can go to analyze, I can go to compare means, independent sample t-test, and I can bring this thing in, and I go to gender, and this gender is coming in here, and define groups. Group number 1 is 1, group number 2 is 2. Don't write male and female here. The computer do not understand male and female, right? So 1 and 2 we fix it, we say continue, and we say OK, and clicking OK would give you an output window. I am coming to this output window now. Now here the things get a little tricky. Remember, we have run independent sample t-test, and this independent sample t-test, that means there are two samples now, right? And the first sample is male and second sample is a female. So male are 92, female are 118. So male mean is 2.05, female mean is 2.11. So we need to see whether this is difference or not. Now on a word I was telling you, I wrote it for you, that there is something which is called as Levine statistic, right? Levine statistic, this is there. This Levine statistic you will find in the output of your SPSS also. So you see that Levine statistic also gives you significance value, right? And it is using f-test. So f-test, if you would go to statistics, it is nothing but it is a ratio of variance test. So the ratio of variance test would mean that it is actually taking the ratio of the variation of the data in the two groups, which is male and female. So that is what I was telling you, to see whether you have homogeneity of variance or not. So it is giving a value of 0.920. So again, the same rules go on in. Let me write it for Levine statistic also, so that you can kind of, it's kind of learning exercise. So what is null hypothesis for null hypo for Levine. Null hypo is there is no difference between the homogeneity of variances across two groups, right? So which means how do you test it? The same thing, I'm copying it and I'm pasting it here. So accept if mean value is greater than 0.05, reject null if, so this is also null, don't confuse it, so this is also null. So accept null if mean value is this, and reject null if mean value is less than 0.05. So here the significance value of Levine is 0.920, which is obviously falling into this category. And if this is the case, we are accepting, and we are accepting what we are accepting, the null hypothesis for Levine. Null hypothesis for Levine, you say there is no difference between the homogeneity of variances test, so which means the homogeneity or variance condition is met. This is wonderful. So there is no difference between the variances of these two groups. So wonderful. So we can go for further analysis now. You can see there are two rows here. So equal variance is assumed and equal variance is not assumed. So equal variance assumed has a row, so SPSS is very kind, it calculates both the things for us. Now, if you would look at this much of the table, this is for Levine, rest of the table space is for t-test, right? It is an independent sample t-test. Why it is called as independent sample t-test? Because here we have two samples, so one is of male, one is of female, and they're independent to each other, independent which is mutually exhaustive. And mutually exhaustive means male cannot be female and female cannot be male. So one who is male, he is not female. So one who is female is not male. So that is why they are independent, absolutely independent of each other. So you use independent sample t-test when you have two samples in such a way that a respondent cannot become part of both the groups at the same time. So either he will be part of this group or he will be part of that group. So this is how call it as independent sample t-test. So now this we have looked at Levine. Levine value is larger than 0.05. So it says so the homogeneity of variance condition is met. So now we look at this equal variance assumed row. So you look at this for this thing, it has calculated a significance value for t, right? So t test for means it has a value of 0.610, right? So we would look at this thing. Now going back to our this thing, which is my word. So if I can do it like this, let me shorten it up so that we can make more sense. So look at this now. Wonderful. So except if mean value, so significance value, it should be significance value, my mistake. It should be significance value. Similarly, you have this significance value. Let me correct it. You should also correct it, right? So significance here is, significance is nothing but it is a p value, probability value, and this is what it is here, significance. So please do not get confused. Except if significance value is greater than 0.05 and reject if significance value is less than 0.05. Here this value is 0.610, which is greater than 0.05. So we are accepting the null hypothesis. And what we are saying, there is no difference between the there is no difference between the means of these two groups. So the means of these two groups were 2.05, 2.11. So we should not treat female as to be a group which is liking the advertising much more than their male counterpart, right? So this is how we kind of interpret it. Many times by looking at this table, you might say, how does it make a difference if we go for Levine test? Because significance for both of the cases, equal variance is assumed and equal variance is not assumed, is same. It is 0.610, it is 610, both same. But many times it so happens that this is not the case. So you actually are in a situation of doldrum wherein this thing would tell you that hypothesis is accepted, this thing would tell you it is rejected. So which one to go with? So that would be told to you by looking at this variance is assumed and variance is not assumed. So if the Levine test tells you that variances are homogeneous, you go with this row significance, which is this. If Levine tells you that the variance is not homogeneous, you go with this row and you look at this 0.610. This is how you kind of look at it. So the interpretation here, what we will do is that there is no difference between male and female as far as their likability to this advertisement which was shown to them was concerned, right? Okay, so this is about t-test. This is the logic of t-test, and if you have this thing which is like uh, this is what we are doing now. Uh, so if you have some questions on this, you can please uh, let me know, because this is kind of very elementary thing about what is t-test. Similarly we have ANOVA also. ANOVA is where we will talk of more than two groups. Here we have only two groups, but in ANOVA we have more than two groups. So it can be like three groups, four groups, five groups, six groups, so whatever number of groups. So ANOVA becomes a little more complicated because it is involving more than two groups. So this is how we look at the t-test, and we look at uh, the one sample t-test and this paired this independent sample t-test. Now what happen in paired sample t-test is you just do the before and after study. So before and after study is when you say, suppose you are suffering from fever, your fever is now 102, uh, and then you take the tablet, and then again after half an hour it is measured whether your fever has come down or not. And when that happens, you actually then see and measure, take the measure again, and suppose it is you say 101 now, or maybe 100. So this is before and after test. So is 100 different from 102? So this is what you will do. So this is about the paired sample t-test. If I can quickly show it to you, how do we do that now? Because I do not have this data which actually supports the uh, which supports the paired sample calculations here, but still I want I would kind of show it to you so that it makes a little more sense. So I am coming back here. So let me take you to the SPSS. Okay, so analyze, compare means, paired sample t-test. So clicking onto this would give you, let me reset it, would give you this window, and you see there is this pair thing. So you have variable 1 and variable 2. Now for example, suppose you have two questions. I like this advertisement very much. When you were shown this advertisement only once, and suppose you have shown this advertisement 10 times to an individual, and then again you ask this question. So the before and after thing. So you would have taken the first thing here, and suppose this is the second question, you would have taken this thing here. And so the two things are with each other now. So this is before, this is after, and the same thing that you do, you click on to OK, and you get the results. And this is the significance that you will check. So here, because I was telling you that this data is little not sufficient, little not kind of good for this type of testing, but I'm assuming that this is the before thing, this is the after thing. So the before mean is 2.09, after mean is 2.26. So it says the significance says equals 0.000, and getting into the word thing, this value of 0.000 is less than 0.05, and we are rejecting the null hypothesis. So this would be rejected, and when this is rejected, we say there is difference. So that means 2.26 is significantly different from 2.09, right? So this is how we kind of look at this. There is one more thing I must tell you. If you would have noticed it, when we have done one sample t-test, when we have done one sample t-test, if I can come to this one sample thing, I think we have done a one sample t-test. We can rename it, no issues. Okay, fair enough. So we go to analyze, we go to compare means, one sample t-test, same thing. I am clicking OK, and you have this thing here. A very important thing to note, when you are running one sample t-test, you do not have Levine statistic calculated by SPSS. SPSS is creating trouble now. Mind it, SPSS do not generate the Levine statistic for one sample t-test because you are only taking one sample, right? So there are no two groups being compared. This is a standard value that you are using. You are typing this value from your end. In contrast to this, when you will use compare means an independent sample t-test, I am pressing OK to it, you will see that the Levine test is now coming in to the picture. So here there was no Levine test, here you have this Levine test, and this is because that now you have two groups, right? So there you have this one group only, so you don't need. So because Levine test was telling the two groups that you are analyzing, are they having equal or proximate equal variance or not. So here you don't have second group, so what do you test for? Here you have two groups, you test for their this thing variance. So now this is why you see Levine statistic for this independent sample t-test, but not for this thing. Again, when you have run this paired sample t-test, you have no Levine statistic, and it is because the same man before and after, it was me only who was suffering from fever, uh, and then I took this tablet, and then it is on to me only that you have measured the fever again. So sample is not changing. When sample is not changing, so you don't talk of comparison of the variation into the sample. So this is the same sample. So that is why you don't talk of Levine statistic. So out of three tests that you do in T, whether it is one sample T test, or it is independent sample T test, or it is paired sample t-test, you do talk of Levine only in independent sample t-test, right? So this is a quick thing about your this thing, right? So if you have any question on this, maybe we can discuss this question, and then so one question is coming up. T-test is usually recommended for small samples. Is it suitable for large group, or any other test is recommended? This is a good question, because if you would go to some papers, you find that the t-test is applied to large samples also, right? Uh, Actually, like any statistic, t-statistic also has a distribution, right? So the distribution of t changes when the size of sample increases, and this distribution tends to follow normal distribution when the size of sample increases to a certain extent. So in statistic we say, if the sample size is 30, if it is below 30 we say it is a small sample, if it is larger than 30 we say it is a large sample. But t-test distribution starts changing when you increase the size of sample. So, and then because its sample because its distribution changes, the distribution becomes the normal distribution. So it behaves like a Z test when the sample size increases, and that is why we still use a t-test even for large samples, because for large samples it is not following the t-distribution, so we can still use it. It becomes the normal distribution. So this I think would make more sense when we would talk of the hypothesis testing. Maybe we can kind of do that also. So thank you for asking this question. Any other question on this? We can discuss that question. And even if you have any question, whosoever is online, you can ask the question if it is around. T-test. Has it made sense to you, or anything that I need to explain again, so that uh, and has it been beneficial? So because then accordingly I will change the things, right? So there is this question coming up. If variance is greater than 1 as sample size approach the 30 size, then standard normal distribution and T distribution becomes equal. Yes, because for a larger sample size, the standard deviation is 1. But there is a trick to it here. You see, when we talk of standard deviation and the normal distribution we talk of Z statistic, and the Z statistic distribution has a variation of 1, standard deviation of 1. It is not the actual thing that you are testing. It is the Z thing. Now if I can kind of tell this thing to you, let me go to Word, and maybe I will try to kind of explain this to you. So what we are discussing now is this. Getting back to my Word, I'm trying to explain this to you, that this is the distribution which is called as normal distribution, right? We have Z. So the normal distribution is of Z. We say that the data is normally distributed. We say it is Z distribution. So the standardized values are nothing but these are Z values. That is how you look at it. You can standardize your data. And you would have also heard that when you would standardize the data would perhaps has kind of more inclined towards the normal distribution. So this distribution is Z distribution, right? So the Z value is x. This is how you talk of minus x bar divided by sigma. Right? This is the value of Z, right? So this is what we are taking. This is your observation. This is your mean. This is your standard deviation, right? This is for your actual data that you collected, and using this you calculate Z, and then the standard deviation that you're talking of, that is of this thing, right? So this is what you talk of in normal distribution and all, right? So this thing, the hypothesis testing, again, because we talk of sampling distribution when we talk of this, we talk of hypothesis testing when we talk of this. So this thing perhaps can be taken up when we will do this hypothesis thing once again, right? Maybe if you feel like that we can talk of this normal distribution and hypothesis testing, we can also talk of that. But to understand any any of these things, and to make sense of all this, there are some things which are super important to understand, and these super important things are the central tendencies, the normal distribution, because you are using normal distribution, right? So you need to know what is normal distribution, you need to know what is standard deviation, you need to know what is central tendency. When you know these things, then you kind of look at these things more carefully, and it makes more sense to you, right? So this is to this question. So anything else on this? uh, any other question about t-test, right? Okay, so this is should I assume that there are no questions now on this, right? So better it is, because because the things are not that simple when we look at the basic thing. Whatever big test that we do, howsoever big it may be, we just should be kind of careful about the basic understanding of all those tests, and all those tests are actually using this thing which is central tendency, uh, which is very basic to it. So everything is using the average, everything is using the central tendency. The basic questions become Why do you have three measures of central tendency? That is more important to understand. Why do we have so many measures of variation also, which is such an important thing? So these are some questions I think we should look at, and only then we will be able to make more sense of this. So this is about t-test from my side. If there are any specific questions, and if you need to ask anything around t-test, you can please ask, right? So I'm waiting for your questions, and then we can kind of think about what do we do next. So it has already been like 1 hour and 10 minutes into the session. So should we cover ANOVA now, or should we continue it in our next session? What is your take on it? So ANOVA now or next session? You can tell me. Is there any correlation between independent groups in t-test? There will always be correlation between independent groups in t-test, but it depends upon in what context you are asking this question. Now, for example, the male and female, the example that we are taking here. If you would talk of the correlation between any trait between the male and female, obviously there will be correlation. You for example, while ago you were doing this question of the suppose the height, mean height of the male and female in class. If you would have these two variables, the mean height of male and mean height of female, so you can kind of find a correlation, which is a non-zero thing. Definitely you will find a non-correlation. See, you have to look at in what context it is called independent. It is they are independent in the sense that one respondent cannot become part of two groups, but their traits are correlated. See, there is difference between traits and the respondents themselves. You see, so the traits would always be correlated. That is what we do in research. But you see, when you talk of the respondent themselves, they cannot be part of the two groups. So this is how you need to look at it. I hope that makes sense for Monica. Shubhadra says, asks, tell us something about measurement scales. Measurement scale is an important topic. I think it will take a lot of time. We can do that. So Shubhadra says, do cover videos on measurements of scales, nominal, ordinal, interval. Yes, obviously, this is very important to know what are the types of scales, because the absolute analysis that you are about to do in future, that depends upon the type of scale that you are using, right? And if you end up in choosing a wrong scale in the beginning of it, you are in trouble, and you are in a huge trouble, I tell you. For example, just to put it in perspective, if you are about to run regression analysis onto your data, regression has a assumption, and that assumption is that your data should be measured on continuous scale. So continuous scale is either interval or either ratio. So if your data is not onto the interval and ratio scale, you would not be able to apply regression analysis. So obviously you need to understand these scales very well, and there is logic why the two scales are called as continuous scales and why two scales are called as discrete scales. So maybe we will kind of touch upon that. So what you can do is, I am leaving my email ID here, right? And you can drop me a mail about the topics which you wish we should cover, and maybe I will take these topics one by one in the next sessions. And you can also send me the feedback of the today's session. I am giving you another email ID of mine, which is linked to this YouTube streaming that we are doing now. So bhagasra@gmail.com, you can write on this, right? So now, just to put this in perspective, that I am a marketing teacher, so and that inclination to is towards research. So I have a lot of videos on research, and I have a lot of videos on marketing. So these videos are available. These are full length class videos, and these are available.